let's look at these types of solids. A lot of this will be review, but it might be good. So ionic solids. This is where ions are attracted to each other non-covalently, and they form a crystal lattice. And the types of crystals we've seen are defined by the types of cubic cells they make, or in some cases hexagonal cells. So all these different ways that the atoms can be arranged are different types of ionic. They represent different types of ionic solids. But the idea is that these repeat over and over again, and you just have a giant repeating crystal lattice, and you can't just identify, oh, here's one molecule of this stuff. You just have a chunk of the solid that looks pretty much the same as any other part of the chunk. Now, metals. Similarly to ionic compounds, metal atoms are also in a type of repeating lattice. So you could also ask about a specific metal, what type of cubic cell is its lattice based on. But different from ionic compounds, metal atoms don't necessarily have a specific amount of electrons that they hold. The valence electrons are very mobile, and it's generally considered that the electrons in a metal are in a sea. So it's really hard to pin down which metal atom owns what electrons. They're more delocalized. Now, molecular compounds, we know that the atoms in them are bonded together through covalent bonds. This is where 2 electrons are shared between 2 atoms per bond. And the individual molecules are separated spatially, and each molecule is the same as every other molecule in a pure compound. And then what's new here is a covalent network solid. In this case, the atoms are covalently bonded together, so between each 2 atoms there are 2 shared electrons. But similarly to ionic compounds and metallic compounds, there is a repeating lattice structure. Last semester we talked about graphite, which is planar sheets of carbon. The carbon bonds together in a way to make hexagons, and each sheet just has more and more hexagons that just keep going in this repeating lattice. So you could call graphite a covalent network solid. And yeah, I mean, you could just keep adding onto this. These hexagons just repeat over and over again to make huge sheets. But the carbons are covalently bonded together. And another similar covalent network solid compound is mica. So this is a kind of complex mineral, and this is a picture of it. It flakes off in these thin planes because on the molecular level there are, like graphite, these sheets, these planar sheets of atoms. And in mica, most of these atoms are silicon and oxygen. So the pink ones are silicon, the red ones are oxygen. And this isn't just one molecule here. It doesn't stop there. It keeps going. We can only really represent a small part of it. So it just keeps repeating these same hexagonal structures.